Hi everybody. In this lesson we want to look at solving some applications that result in rational equations. In particular we're going to look at some motion problems. So here's our first example. It says that the moving sidewalk at O'Hare Airport in Chicago moves so many feet per second. And walking on the moving sidewalk, Camille travels so many feet forward in the time that it takes to travel 51 feet in the opposite direction. So if Camille gets on this moving sidewalk going backwards, she's walking faster than the sidewalk is, but she's only going to go, 51 feet when it's working like a treadmill in reverse, and she'll go 105 feet forward. So if she's going forward, it's, along the side, it looks like she's running. If she's getting on it in reverse, then it looks like she's walking very, very slowly. All right. So we know that in motion problems there's these three variables, and they're related by the fact that the rate times the time is equal to the distance. Distance is rate times time. All right, and there's actually two motions here. We have the motion going forward, going with the sidewalk, and then the motion going in reverse when she's going against the sidewalk. Okay, and the question is, how fast would Camille walk on a non-moving sidewalk? All right, so let's let that be our variable. Let's let x be Camille's rate on a non-moving sidewalk. Okay, now what we know is that this sidewalk goes 1.8 feet per second. Okay, now since the units here in feet per second, let's specify that Camille's rate is also in feet per second, just so we're clear on that in our mind. And so when she gets on that moving sidewalk, she's going to get her rate. So what if she was walking maybe 4 feet per second? Then when she gets on and the sidewalk's going 1.8, then she gets to add the 1.8 feet per second to her rate. So this would be Camille's rate going forward. Okay? And likewise, if she gets on it going in reverse, then it's kind of like a treadmill, and you're going to have to subtract the 1.8. So x minus 1.8, that's going to be her rate in reverse, okay, going against it. So the rate forward is x plus 1.8, and in reverse it's x minus 1.8. And if you think about it, if she was only going exactly 1.8 feet per second, then she would just be standing still, right? If she was just barely going 1.8 feet per second, or maybe a little less than that, then she'd kind of lose distance. She'd go in reverse for sure, okay? So what I do know is this right here, that she traveled 105 feet forward. So going forward, she went 105 feet, and then she went 51 feet in the opposite direction, going in reverse, when she's going backwards against the motion of the sidewalk there. Okay. Well, since I know that rate times time is equal to distance, I know that the time has to be the distance divided by the rate. So this time right here, the time that she goes forward, is going to be the 105 feet divided by her rate, x plus 1.8. And likewise, the time that she goes against the sidewalk there, that's going to be her distance, 51 feet, over her rate, x minus 1.8. Okay, so notice that these times right here, it says something about it up here, that it says she goes the 105 feet forward in the time. In other words, in the same time that it takes to go 51 feet in the opposite direction. All right, so what I know then is that this time going forward has to be the same as the time going in reverse for this other distance. Okay, but that's the key, is that those two times are the same. They're equal to one another. So once I have that, then I see this is a rational equation, and I can solve it. I can forget about sidewalks. I can forget about Camille. I can just do the pure algebra here and crank the handle, and here comes the answer. Okay, so I'm going to multiply both sides here by my common denominator, which would be x plus 1.8 times x minus 1.8. And notice that's the same thing in this case, because this is like a proportion, as just cross multiplying. Okay, so if I cancel what I can there, I got an x plus 1.8 canceling there, x minus 1.8 canceling there. So I'm going to end up with 105 times x minus 1.8 equaling the 51 times x plus 1.8. So let's just solve that very quickly. I'll get 105x minus, I'm going to need my calculator for this. So 105 times 1.8 gives me 189. And over on the right hand side I'll get 51x plus whatever 51 times 1.8 is. That's about 91.8. Okay, so that means that, let's go ahead and bring my 51x over on this side. I'm going to subtract 51x from both sides. That gives me, I think, 54x. And I'm going to take the 189 and add it to the 91.8. So when I do that, I get 280.8. So now if I just divide both sides by 54, so 280.8 divided by the 54 gives me 5.2. Okay, now remember we set up here that x was the Camille's rate on a non-moving sidewalk, so that's going to be my rate. So Camille's rate on a non-moving sidewalk is 5.2, and that was in feet per second. Okay. All right, now we can just check that. Let's see. Let's think about this. Go back and check it. So if she was going 5.2 feet per second, then she gets on this sidewalk that's going 1.8. 5.2 plus 1.8 is 7. So she'd be going 7 feet per second forward. All right. Well, how long is it going to take her to go 105 feet? Well, 105 feet divided by the 7 feet per second. Well, that's exactly 15 seconds, isn't it? Okay. Well, how about going the other direction? Well, if it was 5.2 on a non-moving sidewalk, and then she gets on it going the wrong way, that'd be only 3.4 feet per second. How long is it going to take to go 51 feet? Well, 51 divided by 3.4, well, it's the same, isn't it? It's the same time. It's exactly the 15 seconds. So that makes sense. So it agrees with our intuition what it should be.